Hey, what's up, my dear students? It's Naresh Babu. Welcome back to Physics Crash. Students, in this session, I'm going to discuss about NEET MCQs from 2021 to 23 in work power energy. Let us start the game. Work energy and power. NEET MCQs 2021 to 23. Here the first question. The potential energy of a long spring when stretched by 2 centimeter is U. Look at the figure. So here one spring is stretched by 2 centimeter. So its potential energy is U. If the spring is stretched by 8 centimeter, potential energy stored in it will be. So if we stretch spring 8 centimeter, then what will be its new potential energy? It was given in NEET 2023. Options. See, from these options we have to identify correct answer. Solution. See, we know that potential energy of a spring, that is U is equal to half kx square, where k means spring force constant and x means displacement by the spring. So first we stretch 2 centimeter. So in the place of x I substituted 2, that is U is equal to half k into 2 square. Then we got 2k. Now we stretched 8 centimeter. Then new potential energy will be U dash is equal to half k into 8 square, that is equal to 32k. So here I wrote 32k, 16 into 2k. Here 2k means U. So I got U dash is equal to 16U. That means new potential energy is equal to 16 times of initial potential energy. That is 16U. From the given options, option C is the answer, my dear. Now we will go with second question. Here the second question. An electric lift with a maximum load of 2000 kg, that is lift plus passengers load combinedly they have given 2000 kg, is moving up with a constant speed of 1.5 meter second power minus 1. Look at the figure. So here lift is moving up with a constant speed v, that is 1.5 meter second power minus 1. Okay. The frictional force opposing the motion is 3000 Newton. So here frictional force opposing the motion of lift, that is 3000 Newton. Okay. The minimum power delivered by the motor to the lift in watts is. So we have to calculate minimum power delivered by the motor to the lift. It was given in NEET 2022. Options. So from these options we have to identify correct one. Solution. See, from figure we can write lift force is equal to weight of the lift along with passengers plus frictional force. Why? Why? Because here lift is moving with constant speed. So net force will be 0. So net force 0 means upward force equal to downward force. So here upward force lift force and downward force weight of the lift with passengers plus frictional force. So we got upward force is equal to weight plus frictional force. That is equation 1. So here W means mg, m means 2000, g means 10. So we got 20,000 Newton. From 1 we can substitute in equation 1. Okay. W place 20,000 and frictional force 3,000. So we got F is equal to 20,000 plus 3,000, that is equal to 23,000 Newton. So now we will calculate minimum power delivered, that is power is equal to F into V. So F means 23,000 here, V means 1.5. So if we multiply, then we will get 34,500 watt. So from the options, option B is the answer, my dear. That is power delivered by the motor to the lift, that is 34,500 watt. Okay. Now we will go with third question. Here the third question. A particle is released from height S from the surface of the earth. Look at the figure. So here one particle is released, okay, from the height S. So it is a freely falling body, initial velocity 0, okay. At certain height its kinetic energy is 3 times its potential energy. See, at certain height, that is from the ground, it is h, at which kinetic energy is 3 times of potential energy, okay. The height from the surface of earth and the speed of particle at that instant are respectively. So we have to calculate this height, okay, and this speed at which k equal to 3 times of potential energy. It was given in NEET 2021. Options, from these options we have to identify correct answer. Solution. See, we know that total energy is equal to sum of potential energy and kinetic energy. So here potential energy plus kinetic energy, here at certain point kinetic energy is equal to 3 times of potential energy, that is equal to total energy. Total energy means, see, at a releasing point total energy is mgs, that is potential energy, okay. So at releasing point we have only potential energy, that is nothing but total energy, that is mgs. So in the place of total energy I wrote mgs, okay. Then PE plus 3 PE means 4 PE. So 4 PE is equal to mgs, okay. So here PE means mgh. So 4 mgh is equal to mgs. That implies h is equal to s by 4. So we got this height, okay, from the ground, okay, at which k equal to 3 PE. So we got height, that is h is equal to s by 4. Now we have to calculate this v at which k equal to 3 PE. That is v square minus u square is equal to 2g h dash. So here height is h dash, okay. This h dash is s minus s by 4, then we will get h dash 3s by 4, okay. Now if you substitute, then we will get v square minus u means 0, that is equal to 2g, this h dash, that is 3s by 4. Then we got v is equal to root over 3gs by 2. So finally we got speed at which k equal to 3 times of PE, that is root over 3gs by 2, okay. And also we calculated this h, that is s by 4, okay. From the options, option D is the answer, my dear, okay. Now we will go with fourth question. Water falls from a height of 60 meter at the rate of 15 kg per second to operate a turbine. The losses due to frictional force are 10% of the input energy. How much power is generated by the turbine? So we have to calculate power generated by the turbine. That means here water is falling from a height of 60 meter at the rate of 15 kg per second. to operate a turbine. So due to that there is a loss of energy due to frictional force. Okay, that is how much? That is loss of energy is 10% of the input energy. Okay, then how much power is generated by the turbine? So we have to calculate power generated by the turbine. It was given in NEET 2021. Okay, here G equal to 10 meter per second square. Okay, check the options. So from these options we have to calculate answer. So solution. So we know that input power is equal to mgh by t. So m means 15. Okay, g means 10, h means 60. Time per second they have given, so time is 1 second. If we simplify we will get 9000 watt. Here there is a 10% of energy loss in input energy, then output power is equal to, okay, 90% of P input. So 90% means 90 by 100 into power input, that is 9000 watt. Okay, so if we simplify here we will get 8100 watt. Okay, that I can write 8.1 kilowatt. Why? Because 1 watt means 1 by 1000 kilowatt. So we will get 8.1 kilowatt. So from the options, option B is the answer, my dear. Now fifth question. The energy that will be ideally radiated by 100 kilowatt transmitter in 1 hour is. So we have to calculate energy radiated by transmitter. Okay, if its power is 100 kilowatt in 1 hour. Okay, so it was given in NEET 2022. Here are the options. From these options we have to identify correct one. Solution. We know that energy is equal to power into time. So in the place of power we will substitute 100 kilowatt into time 1 hour, that is equal to 100 kilowatt hour. So 1 kilowatt hour means 3.6 into 10 power 6 joule. So we got 100 into 3.6 into 10 power 6 joule, that is equal to 36 into 10 power 7 joule. Okay, from the options, option D is the answer, my dear. That's about this session, my dear. I hope you like this session. If you like it, please put the like. Thanks for watching my video. Please subscribe and share it. Bye, students.